Welcome back to our podcasts on the TI-83 and TI-84 calculator. This is Session 1, Calculator Basics, Module 3, Graphing Basics. My name is Bob, and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is the third module, and we're going to cover, as I said, Graphing Basics. In the first module, we covered the layout of the calculator keyboard and the home screen. We looked at editing calculations and the order of operations, or PEMDAS. In the second module, we covered basic mathematics functions such as powers and roots, absolute value, the greatest integer function, and we also looked at the calculator mode. In this module, when we're done, you should be familiar with setting up an equation so you can enter it into your calculator. We'll look at the y equals screen. We'll learn how to graph an equation that you've put in on the y equals screen. We'll look at adjusting the window, both manually and with the zoom key, and we'll learn a little bit about the trace key. To graph an equation, it must first be put into the form of a function, y equals f of x. The right side must not contain any y's. So suppose, for example, you were given a linear equation in its general form, ax plus by plus c equals 0. You would have to convert it outside of the calculator on a piece of paper all by yourself into a form that's acceptable. For example, the slope-intercept form. The slope-intercept form is y equals mx plus b. Not all equations are functions. The equation for a circle is given as x squared plus y squared equals the radius squared. You cannot put that in because if you solve for y, you would end up with y equals plus or minus the square root of r squared minus x squared. That's not a function because there's two values of y for each value of x, and it fails the vertical line test. Let's try a specific example. Let's enter the equation 3x plus 2y plus 4 equals 0 into the calculator. First, we must convert the equation to look like a function. We're going to subtract 3x from both sides, and we get 2y plus 4 equals minus 3x. Now we're going to subtract 4 from both sides, and we get 2y equals minus 3x minus 4. Now we divide both sides by 2, and we get y equals minus 3 over 2x minus 2. Let's now turn on the calculator and enter it into the calculator. First, we're going to get to that y equals screen, and you know that the top left-hand button is the y equals button. Press it, and we see the y1 equals, y2 equals, y3 equals. We can enter multiple equations if we want to here, but we're only going to deal with one at a time when we start. Though we decided that this function is y equals minus 3 over 2x minus 2. Let's enter that. So we're going to start with the opposite of, parentheses, 3 divided by 2, parentheses, times x, and we hit the xt, theta, and n column button to get the x, minus 2. And now we've got the equation loaded into the calculator. We can press the graph button on the top right-hand side, and we should be able to get a graph of that line. That seemed pretty straightforward, didn't it? Let's go back to that y equals screen, and let's clear that equation, and we can clear it by moving up to that line and pressing clear, and you can see it's all gone. And let's put another equation in. Suppose we had x squared plus 20. Well, I put in the x, and I use the xt, theta, and n button again. Hit the squared key, plus 20, and now let's graph it. And I graphed it, and nothing happened. What's going on here? Well, if you look at what's showing on the screen, we've got something that looks like it's going from about minus 10 on the x value to plus 10 on the right, and plus 10 at the top, down to minus 10 at the bottom. And what's happened is our graph is out of that range. This window, that we call it, does not cover the area where our graph is. There are lots of ways of adjusting the window so that we can bring our graph into focus, if you will. Let's try it manually first. We would press the window button on the very top there, and you can see that the window says we're running from minus 10 as our smallest x value to plus 10 is our largest value, and the x scale is 1. That means the tick marks are going to be 1 apart, and our y min runs from minus 10, our y max runs to plus 10, the tick marks are 1 apart, and the resolution is 1, and we don't usually fool with the resolution function, so we won't worry about that. Well, if you remember, our equation was x squared plus 20. That means our smallest value is going to be 20 in the y-axis. So let's go down and we'll change y min to, let's say, 15, and we'll change y max to 25. We won't make any other adjustments, and we'll hit graph. And now you can see that the equation has come into focus. It's in our window. Notice that there's no x-axis on this graph. It's just a dotted line. That's because the x-axis is out of focus, or out of the range of the y values that we've put in. Let's go back to the y equals screen by pressing the y equals button. And from here, let's enter that original equation. We're going to scroll down to the y2 line this time for the second equation, and we're going to put in parentheses, -3 divided by 2, parentheses. I'm just going to put xt, theta, and n here. I don't need the time sign because it's implicit multiplication, -2. Now let's graph again that function. And notice I've got the one function on, but not the other. Well, how can I return to that original screen without going back and manually re-entering what the screen is? One of the things I can do is hit the zoom key. Let's do that. And on the zoom key, there are lots of different zoom options. We're going to go down to zoom standard. And zoom standard always sets us to the standard window, which is that plus and minus 10 for the x value, and plus and minus 10 for the y value, with the tick mark every space. Let's hit enter, and you can see that in a second our line comes back, but we've lost the parabola. Suppose we wanted to get both in. Well, just like a camera, you can zoom in and out. You can zoom in and out with your calculator. Let's zoom out until we have both the line and the parabola on the calculator. I'm going to hit the zoom key, and to zoom out, we go down to 3, and we can either hit the number 3 or we can scroll down to 3. Press enter. Now, every time you press enter hereafter, it will zoom out 1. So it's going to zoom out 1, and you can see there's the parabola, and there's the line. So we've got them both in an area. But it's pretty scrunched together, and we'd like to maybe just look at these in a little tighter window. Well, another zoom function is Z-box. Let's take a look at that. We're going to hit the zoom function, and the very first one is Z-box. We're going to hit enter, and now you can see there's a cursor flashing. It happens to be right at the origin right now. We're going to move that until we're at the top left-hand corner of what we want to graph. And you can see it moving across as I press the left button, and now moving up. And we're going to hold it until it goes up a little bit. And we're going to try and get both some of the parabola and some of the line in focus. I've got what I want to be my upper left-hand corner. I hit the enter button, and now I scroll to the right. And you can see as I hold this down, it goes further and further to the right. I've got the parabola in. Let's scroll down, and you can now see why it's a Z-box. You can see a box being created. And now I've got a Z-box that has both axes in it, a little bit of the parabola and a little bit of the line. If I press enter, that'll become my new window. And you can see the piece of the parabola, and you can see the line. So there's another zoom function that allows us to look at two things that we want to look at. If we wanted to zoom back in, we could certainly zoom in. But if we zoom in, we're going to zoom right in the middle of that screen. So let's hit zoom. We'll go to zoom in. And just like zoom out, you have to hit enter a second time to zoom in once. And we've zoomed in, and you can see we zoomed in so close that there's nothing left on the screen. Let's look at another zoom option. Let's go to the y equals screen, and let's clear both of those equations. Clear the top one, clear the next one. Remember we said that a circle was not a function, we would have to enter it as two functions? Let's do that. Let's put in the square root of 16 minus x squared for the first equation. We do that by second square root 16 minus xt theta and n squared, closing parentheses. Press enter, and we go down to the next one, and now we want the opposite of second square root 16 minus xt theta and n squared, closing parentheses, and press enter again. Now let's graph that. Well, the functions aren't there because we're out of range. Remember how we said we could get them in range? Let's hit zoom, and we'll go to zoom standard down here at number 6. Well, there's our equation, but it doesn't look like much of a circle. It looks more like an ellipse to me. It's kind of squishy on the top and squishy on the bottom. Suppose it was really important for us to see that was a circle. One of our options is to do zoom square. Let's hit the zoom key, and we'll hit number 5 for zoom square. And now you can see that it's adjusted the tick marks so that the tick marks up and down are spaced identically to the tick marks left and right. And our circle now really looks like a circle. Let's take a look at something else. Let's go back to the y equals screen and clear both of those equations. Clear, and down one, and clear. And let's go back up to y1, and let's put in the equation x squared minus 4. All right, again we put in xt theta and n squared minus 4, and we'll graph it, and you can see that we have a parabola. Now suppose we wanted to find out what those intercepts were. One of the ways we can do that is by tracing the function. Let's press the trace key up next to the graph key. And you can see there's a little cursor there, and that cursor we can move left and right and it will trace along the function. We can see at the top that the function is identified. It's y equals x squared minus 4, and that current point is x equals 0, y equals minus 4. As we move to the right, you can see that we slowly go across, and if we were trying to find where it crossed that axis, it looks like at x 1.935 it's slightly below, and at x at 2.25 it's slightly above, and we would guess that maybe it crossed the axis right around x equals 2. Well, it's not very convenient that this thing is stepping around in increments that are really kind of weird. Suppose we change our window and change it to a z decimal window. Let's hit zoom. We'll go down to z decimal. Okay, and now you can see that we've got the parabola brought much more clearly into focus. We'll hit trace. Notice that it says that we're at x0, y minus 4. We're slightly off the screen. But now as I move to the right, notice that it moves in even increments of a tenth. So there we are at x equals 1, 1.1, 1.2, 1.3, 1.4, 1.5, and we can hit exactly x equals 2. We can move to the other side. And it's coming back into the screen there. And you can see it's exactly x equals minus 2. So the z decimal windows gives us steps that are exactly 1/10 apart on the x-axis. The y values will be whatever the calculation results, but the x values will always be 1/10 of a step apart. Let's go back to our y equals screen, pressing y equals, and from here, I want to look at that original parabola we looked at. Remember that was x squared plus 20? Let's scroll over. We're going to change that minus to a plus, and we're going to change that 4 to a 20. And let's change back to the standard window. And we're going to do that by hitting zoom and zoom standard. And as you will recall, this one was out of focus. There's another way to bring it in, and that's called z-fit. So we're going to hit zoom, and you see down here number 7, there's an arrow instead of a colon. That means there's more options underneath that. So we're going to scroll down beyond 7, and you can see 8, there's z integer, and 9, there's zoom stat, and 10, or 0, is zoom fit. So we're going to hit zoom fit. And if we hit zoom fit, it didn't change the x values at all, but what it did was it changed the y values so that the smallest y was the smallest y on the screen, and the largest y was the largest y on the screen, and it basically made it, it didn't change the x range, but it did change the y range. Let's hit window and take a look. Notice that our x min was minus 10 and it remained unchanged. Our x max is still plus 10. Our y min is now 20 and our y max is 120. It brought that parabola into focus for us for the range, or for the domain of x's that we were looking at. Let's press the graph button and move over to that graph. Notice that if we hit the trace button, we can move along that line by using the left and right buttons, but the up and down buttons don't do anything for us. Well, they have a special meaning. Let's put another equation in here. Let's go back to y equals, and let's put in y equals x plus 25. So we hit xt theta n plus 25. And let's go to the graph, and you can see that we now have a line that's going through that parabola at the very bottom there. Now hit the trace function, and I'm going to just hold the trace button down for a second, and you can see that we're tracing along the parabola. And I've gotten pretty far up on that parabola. If I hit the down button, it jumps down to the line, and now it traces along the line. Using the up and down keys for the cursor causes you to jump between the various graphs that you have on your screen. Let's try one more thing with this. We're going to do a zoom box to bring the area down around that point of intersection into focus. So I'm going to hit zoom and number 1 for Z box. I'm going to bring the cursor down a little bit and then over to the left and down a little bit more and try and get an area that we can bring this into focus. Grab a corner, go all the way to the right, go down a little bit, start to open that box up, go a little bit more to the right, and I've got it the area I want. I'm going to press enter, and you can see that now I've zoomed in on this a little bit better. I've zoomed in better, but if I hit the window function, you can see it's a pretty strange looking window. Let's go back to the graph by hitting the graph key, and we're going to try a different zoom function. We're going to try zoom integer. An integer is down below the trig button, so we're going to scroll down, and down arrow says there's more there. There's zoom integer at number 8. Press enter, and now the cursor is flashing because it asks where do I want to center it, and I hit the center and I hit enter, and it zooms in and centered it right in that area. Let's just briefly summarize some of the different zoom settings that we've seen. Z standard sets a standard window where the lowest value of x is -10, the highest value is +10, and the lowest value of y is -10, and the largest value is +10. And the tick marks are one apart. Z decimal sets a much tighter window, with x running from -4.7 to +4.7, and y running from -3.1 to +3.1. But the neat thing about Z decimal is that when you trace, the x moves along in tenths. We didn't look at Z integer, which is a very wide window, but very similar to Z decimal. In the Z integer function, the whole steps move along in increments of 1. Z-trig is something that you'll use in calculus, pre-calculus 2. We're not going to cover that right now. Zoom fit leaves the x values unchanged for your window, but adjusts the y values for the window so that for the portion of the function that we're looking at, the y is in focus. Z-square makes the window square so that when it's important to see exactly what shape a graph has, you can see it. That's what we did with the circle. And Z-box allows us to zoom in a special area of the box. We also looked at zoom in and zoom out, just like you zoom in and zoom out an equation. So let's summarize what we covered in this module on graphing basics. We learned how to set up your equation, and it must be in the form of y equals. We learned how to graph an equation by putting it into the y equals screen and then pressing the graph button. Then we learned how to adjust the window so that we could either adjust it manually or use the zoom key. And finally, we used the trace key to move along a line so that we could see where it intercepts various points, and we also learned how to toggle back and forth between two different graphs on a window. This finishes Module 3 on Graphing Basics. Current students at Raritan Valley Community College can get additional support by coming to the Academic Support Center. The Academic Support Center is open during most school hours, and you can check the hours by going to the web, www.raritanval.edu, and looking under the tab Current Students, and under Academic Resources, look for the Academic Support Center. The Academic Support Center offers a wide variety of tutoring assistance from math and English to the sciences and various humanity courses. The Academic Support Center is there to help you.